Today I'm going to talk about Spring Kafka and our journey in ING around Kafka. First of all, I'm Tim van Baarsen. I'm a software engineer at ING, and I'm part of the Kafka team in the Netherlands. We basically have a team half in Romania and half in the Netherlands. And our team name is Dora. Great, thank you. That will make it a bit comfortable. Okay, and the team Dora is a big wing to Franz Kafka, who sends a lot of messages to his fiancée Dora. So it's a bit of a wink to that story. We're active in more than 40 countries around the world. Kafka is heavily used in ING. I think we can say we are front runners in Kafka. We're running Kafka in production for over 7 years. We looked up the numbers this morning with my colleague. Of course, we know what's going on, but we have more than 5,000 topics in production. And we are serving more than 1,000 development teams around the globe with Kafka. So we're really proud that we can be there and have this available for those teams. We also offer a self-service portal so teams can create their topics. They are basically, when they create a topic, they're the owner. They decide the settings on the topic. They decide who can read their data from that topic. And we help them to support them in their Kafka journey as well. So we help them with support. We do some consultancy with them to get the most out of Kafka. We use it for many different patterns. Some teams are just using Kafka to ship metrics or logs to Kafka. Some teams are using it for streaming analytics, for all kinds of use cases. So it's pretty big. And the traffic on Kafka is still growing. It started with a small tickle, and now we are basically have a flood of messages coming in every second. And on average, we nearly touch the 1 million events, messages, or whatever you want to call it, a second. And yeah, with the upcoming holidays, Christmas, it will only go up and up. So on average, every month, 10% traffic increase on Kafka. So it's quite a big nervous system within ING. Okay, today, what's on the agenda? I can imagine some people never used Kafka, so I'll do a really quick nutshell introduction to Kafka. Then we move on to Spring Kafka. And then I would like to show you some real demos. So we're going to break stuff, we're going to fix stuff. So we're going to look at the poison pill scenario, also known as a deserialization exception. Also, some cases around the lack of error handling and exception handling. Then we touch a bit on integration testing, or maybe not to do integration testing. How about monitoring? And then we sort of wrap up with the lessons learned, and hopefully I'm fast enough to let you guys ask some questions. Okay, really in a nutshell, Kafka is a distributed system. There's a broker. Actually, there are multiple brokers, part of a cluster. And for the purpose of the demos, I'm using a topic that's called stock quotes. We're in the banking domain. I worked at investments in ING. So to get some traffic in, we constantly have stock quotes that are basically reflect stock trades on the stock exchange, and we will publish them basically in the topic. A topic consists of multiple partitions, so we can scale out the data, and we can also scale out the consumers. So we have a producer here on the right. It's basically sending data to Kafka, and yeah. How does it look like, right? One record in Kafka is basically, can have a key. So in this case, it can be a symbol of a stock, of a unique stock, not a unique trade. So for let's say, an ING stock, we will produce an event to Kafka when it is traded. When another comes in, we basically produce another record onto Kafka. And if we have a key, then Kafka guarantees for that partition, it will always end up in the same partition, so you have guaranteed ordering in the partition. What you see here are not the keys, but it's basically the offset of the message in that partition. Along with the actual payload of the message, it will also send some headers, and we will see that in action when we go into, for example, distributed tracing over Kafka. So some data will come in. It was basically a stream of data. So we have a producer in this project I'm going to show. And then we have a consumer, or maybe even a Kafka Streams application that's basically consuming the data, and it's subscribing to a topic, deserialize the data, the producer actually serializing the data before it goes to Kafka, and it actually sends a heartbeat, so Kafka knows that the consumer is still alive. Kafka itself, and I think it's really important to understand before we go into the demos and crashing stuff, Kafka is not responsible for any type checking, schema validation, or any other constraints, because in the end what you send to Kafka are just bytes. So the producer, whatever this object is, it will somehow serialize the data before it ends up on Kafka, and the consumer is basically doing it the other way around. And Kafka is really good at basically shuffling around bytes. That's all what Kafka is doing, and that's why it's super fast. Of course, when you create an event or a message, it's not a free format, right? Because the consumer should know what to expect. So basically, we help the teams with creating Afro schemas, and it's basically a contract between the consumer and the producer. So in this demo, we're also going to use the Confluent schema registry, where the schema is basically stored. So the responsibilities are storing those schemas, also serving those schemas to the consumer. And it's basically also doing some schema validation. So what the producer is actually sending, is it matching the schema? Otherwise, it will not end up on Kafka. And it also helps you to do some schema evolution, right? Events will not always stay the same. You will add fields, remove fields, so it will make sure that you don't break your downstream consumers. So this is really, in a nutshell, Spring Kafka, and you will see those components in action. I also have a Kafka Streams application, but I just didn't have enough space to fit it in the screen. And it's really, to emphasize again, you have a pair of serializers and deserializers. As long as those are in sync, you're fine. If you're not, we're going to show you what will happen. Okay, then really quickly into Spring Kafka. So we have a broker, we can connect to it, we have the rights to produce to it or consume from it. You can still use the Kafka client libraries, right, to just one-on-one integrate on Kafka. That's all fine. But I like to use Spring Kafka that has a little bit more abstraction on top of the core Kafka client libraries. So it has some built-in support for error handling, recovering records that cannot be deserialized. That's all what Spring Kafka offers, basically. And then in your user code, you use, for example, a Kafka template. You can compare this with a Redis template or a JDBC template, right, to produce data to Kafka in a really convenient way. You can annotate a method on your component as a Kafka listener, and it will basically act as a consumer, and that data will come in. Next to that, Spring Kafka also provides a testing library. So if you would like to spin up a embedded Kafka inside of your test, you can do that. We also look into what other possibilities are there. For example, test containers is one option, but later I will deep dive into that. This is the embedded Kafka annotation for testing, and some annotations about streams, right? There are way more things to it, but just to get a little bit of an overview. So this is basically a piece of code for a producer. It's a Spring component. We can auto-wire a Kafka template, and they use the Kafka template to say, okay, this is the topic, this is my key. So in this case, it's a symbol. It will be routed to the correct partition, so you have ordering. And in this case, we will produce a stock quote. The stock quote object is basically generated out of the Afro schema, so both the producers and consumers are using the same definition. And in this case, it's super simple. We just send the data to Kafka. A consumer is maybe even more simple. It's just an annotation. We say we would like to consume from this topic. Here is the stock quote object again. And additionally, I added one of the other annotations to also read some Kafka headers. In this case, we print the partition the data is consumed from. Now, so we touched on producers, consumers, but in many cases you would like to do real-time processing on streams, maybe joining different streams of data together and push it out to another topic. For today, although we go a bit beyond the basics, this talk is not about Kafka Streams, so I try to keep it a little bit simple. So what we do basically here in this piece of code, it's the Kafka Streams application that I'm going to show, is we consume the stock quote topic, and based on the stock exchange the stock was traded on, we basically split out, we branch out to different other topics. So if it's traded on the NASDAQ, it will go to a different topic. If it's traded on the New York Stock Exchange, it will go to another topic, etc. And if it doesn't belong to any of those, then it will basically go into some kind of bucket for all the other stock exchanges. And this is another abstraction on top of K-tables, Kafka Streams, that is provided by Spring Kafka. If you do it with plain Spring Kafka library, you have to build a bit more code. So that's another way of doing it. I like it. Of course you need a little bit of configuration. So primarily we have to specify the broker, of course. Then it will also know about the other brokers in the cluster. And here you see again that the key serializer and the value serializer come into play before data is sent to Kafka. So in this case, we're also using the schema registry, so we also specify the URL of the schema registry here. So we are ready, right? We can go to production. But yeah, what kind of exceptions or what kind of scenarios will you discover along the way? And to be honest, I made a lot of those mistakes myself. So basically you're happy, but after the honeymoon period is over, you fall into some traps. You learned things the hard way. And today I would like to share a bit of those tips and tricks to apply maybe your own project and share with your fellow developer colleagues. Don't tell my wife I use this picture in the slides because she will kill me. But let's get started. First of all, I'm running everything locally, not because of the Wi-Fi here, but also because I really like to have really fast feedback cycles. So I run a single node Kafka cluster on my machine with Zookeeper, with the Confluent schema registry. I have some tools to inspect what's going on the topics. There are many CLI tools for you to check out. And for today, I will using a conductor. There are many other UI tools to see what's going on the topic. For example, Confluent Control Center or Claw. You can basically pick a lot of tools, but for today, I'm using a conductor. And this will help me to get a fast feedback cycle. I can run everything locally, can try out stuff. And the first thing I would like to show is basically a poison pill scenario. So, okay, let's start. What's a poison pill anyway? A poison pill is basically a record that ended up in Kafka, and your consumer can basically not deserialize this message. It can try it 1 time, 1,000 times, 1,000,000 times without any change or configuration change. You will not be able to basically swallow this poison pill. It can come in different formats. It can be a corrupted record. This is quite rare on Kafka. I never encountered this myself. In many cases, this is basically a deserialization failure that I'm going to show you in a couple of minutes. So really quickly go back to the setup here. In the demo, I'm going to use a different producer. I'm going to use a console producer that's basically bypassing Afro all the way. It's going to send a poison pill directly to the topic. And then we will see that basically the consumer will have a hard time because it cannot deserialize this message. Because a lot of people think, oh, I'm using Afro, I'm protected, everything is fine. But think twice. If you use another application, in this case I'm using the console producer because it's easy to show, things can go wrong and can go horribly wrong because you will basically end up in an infinite loop. So, once again, somebody produced a poison pill. So we first have an Apple stock, an ING stock, and then this pill comes in. The consequence is basically that you block the consumption of that messages from that partition on the topic. Whatever valid message comes afterwards, you will not hit that point. You're basically stuck, you cannot swallow it. It will try again and again and again, very fast, and it will also log a line for every failure. So if you come back the next day, your whole disk is full. Maybe you ship off this to a distributed logging system. Also, people there are not happy with you. And before you know, you end up in a really nasty situation. And I've been there a couple of times and made this mistake myself. It's not only your consumer, right? Maybe there's another application, another consumer group that is hitting the same issue if they don't configure their application properly. Okay, so what can we do? The impact is quite high, and what we see some teams doing, they sometimes even wait until the retention period is over. Kafka will store the data for you for 7 days. Shut down your application, wait 7 days, the poison pill is gone, and then you start again. But this is, of course, not something you can you are willing to do. So that's a no-go, right? You can change the consumer group. You're basically registering Kafka as a new, let's say, consumer, and you say, I'm just starting from the latest point in the topic, so basically beyond that pill. But yeah, all the messages in between, you will not see them. So this is, of course, also not really acceptable. You can manually or programmatically update your offset. Could work, but what if there's another poison pill down the line? Yeah. So I think the best way to solve this is to use Spring Kafka and use a error handling deserializer. And that's actually what I'm going to show in the demo. So I started up my project here in IntelliJ. Let's start the consumer, the producer, and the Kafka Streams application. Let's see. Yeah. So this is just a Spring Boot application that's using Spring Kafka, and it's basically producing a message every second. So the producer is started. Then we can use a different application. It's basically consuming the data. It's just printing out that consumed message for now, just to keep it simple. So everything is fine. Stock ticks are coming in. And I'm also going to start my Kafka Streams application that's doing the branching based on the stock exchange. Quickly going to see if Conductor already started here. And Conductor will give me a console, a nice UI console, so we can see that the stock quote topic is there. We can see that messages are coming in. We can even see the data produced, and we can see that actually the Kafka Streams application also started and is basically branching based on the stock exchange. So now, okay, everything is fine. Let's now go into the broker, and I'm going to use the console producer, to get into some trouble. So we go into the terminal. Let's make it a little bit bigger here. Is this visible in the back? Cool. Okay. My whole setup is also running with monitoring, so I just need to insert a JMX port for a sec, and then we will basically start producing. So this is the console producer that comes with the Kafka distribution. I started up, and it's now basically waiting for my input. And look what I found here. I found a nice pill. So let's try to publish this to the topic. Once again, we are not using Afro here, so we're just directly pushing this message to the topic. And I feel my machine is already getting a bit slow, and boom, it's now going into this infinite loop. Kafka Streams is a bit more forgiving, although it will basically shut down the stream thread for you if there is a serialization exception. But for a consumer application, by default, you will end up in this scenario. So before my whole disk is full of logs, let's stop this. And how to fix it. That's what we're going to do next, basically. So we go into the configuration. Let's see. Oops. Okay, let's make it a bit bigger. So this is the configuration for the consumer. By default, it has the deserializer for the key and the value. But there is basically no way to intercept this, this exception. Spring Kafka came up with a error handling deserializer, and it's a really smart thing. So you basically configure this deserializer for both the key and the value, because the exception can occur on both the key and the value. And you basically delegate to the actual deserializers that you specify here. Yeah, and then we can start the application. So basically, the message will come in via the error handling deserializer, will be delegated to the actual deserializer. When an exception occurs, Spring Kafka can sort of intercept, and by default it will just log and continue. Might not be sufficient for all use cases, but at least you don't end up in this infinite loop. So let's hope the demo gods are with me today, and let's start the consumer application again. Of course, the producer is not aware of this consumer, right? It will just continue producing. So we are actually already lagging behind. So if you're into real-time critical applications, this is something you definitely have to look out for. So it's going really, really quickly. You see it hits this deserialization exception. It will not try again, and yeah, basically log this error and continue. So at least we survived this poison pill. The same thing you can basically do for Kafka streams, but I think you get the point by now that your application should be resilient to those kind of use cases. Let's quickly do one other thing I would like to show. And that's a bit of configuration where we can actually say, we now printed the exception, but we lost the message, right? In this case, it's a poison pill. So is it really useful to recover those? Maybe not, but in other cases, you might still want to see and inspect what happened, and you would like to see this message. So what Spring Kafka can do, by default, it will just log it. We can also configure a that letter publish recover. So it will basically publish this message to a dead letter topic, so you can inspect this later on. I will restart the consumer one more time, so we can see this in action, and it will also help me with the next demo to get this up and running. Okay. So I think it started again. Let's go back here, and instead of the poison pill again, we're going to say hello JFall. This will trigger, of course, another deserialization exception. We protected the application. We can see it here. It happened. It hopefully recovered, so let's see. Okay. Maybe I'm missing something here. Yeah. Quickly take one look. Yeah, of course, I need to tell it, because what basically happens now, the default error handler will be wired by the auto-configuration of Spring Boot, but I need to tell it to basically use a default error handler. No, it's going. Yeah, with a. Sorry, this is fine. So once again, it needs to know that I would like to recover this message. So I need to wire a different way of handling the exception. So let's try to start one more time. That's the tricky part with live demos, right? Okay, so we started the application again. This time it was right. So deserialization exception happened. we configure to recover, and the recovery path is basically to produce another topic, and by default, Spring Kafka will make a topic for you, the name of the topic, and then DLT, that stands for dead letter topic, and we can basically see the message that we just produced. Okay, so that's what I wanted to show for the poison pill demo. And now you might think, yeah, Tim, it's all nice, right? But you use this console producer. That will never happen in production for us. Yeah, that's fair. But what about end-to-end encryption on Kafka topics? By default, Kafka doesn't have a way to protect your or encrypt your data in REST. So what we do in ING, if we're talking about critical data, customer data, we have to encrypt it, right? So then we have a customized Afro serializer that basically is using a shared secret between the producer and the consumer, or the Kafka Streams application. So people think, okay, Afro, it's all fine, we have security in place, but then the producer will change the secret. That's another scenario that can happen. If you don't communicate this to your downstream consumers, they will basically break and end up in a serialization exception. So this is a real-life scenario that we sometimes see in production. People are in panic because they don't know what's happening. So I think this is still something to keep in mind. All right. So next scenario is basically the lack of proper exception handling in your own code. This is actually before the data reaches your method that's annotated with a Kafka listener. But what happens if you make a mistake yourself, or you're calling a downstream service that's not responding? And in this case, I keep it simple again. My consumer is just a shaky implementation, and when I send a stock with a symbol and that has kaboom in the name, then we will throw a runtime exception. And this is really obvious, right? But just to show what will happen. By default, Spring Kafka will retry 10 times. Hopefully you can recover from this exception, but in this really obvious case, after 10 times, the message will be lost and will be logged. And I think that's not really useful, and in many cases it's even unacceptable to do this, because you're basically going to lose that message. So the impact really depends on your use case, right? So if you're shipping logs, yeah, okay, you can lose a metric or a log, but for transactions or other important stuff, you can basically not tolerate that. So Spring Kafka got you covered again here. You can replace the default error handling with a common logging error handling. Maybe you would like to completely stop the application, or at least stop consuming, let's put it that way. So you can basically, based on your use case, you can choose what to do. So you can stop consuming, or you can use the consumer record recovery we just configured for the poison pill, also to basically put that data into a dead letter topic so you can inspect what's going wrong. Of course, you have to be aware that maybe some messages will come true, others will not become true. So in many cases, you will find yourself in a situation, can I basically execute this again? Can I consume the data from the dead letter topic again? And is my downstream service, or what operation will be invoked, is that item potent? You also have to think about that. Also, in the latest version of Spring Kafka, there is an experimental feature for non-blocking retries. I'm not going to show that today, but if you're interested in that, that's also a possibility. And of course, like everything with Spring, you can also implement your own strategy and implement your own recoverer. But it's up to you. So another demo here. Okay. So to trigger this scenario, I exposed a little REST endpoint on my producer, so I can actually send a REST call, and that will produce a message to Kafka. And I'm using the HTTP client of IntelliJ here to call my stock quote API. And yeah, we have this kaboom symbol in here. So let's see if it will trigger this exception for us, and let's see what will happen. So we send a message to the REST API, and it's basically just a pass-through to a Kafka template that will produce it to that topic. Of course, this consumer is still running, and let's see. So many things going on. Yeah, it's going quite fast, of course. So I have to scroll a bit back. And you see that the code, let's show it one more time to make it clear. This is the code. It will match this, this condition, and will throw a runtime exception. We will see that it will actually try 10 times, and because we configured the error handler together with the recoverer, it should now end up on this topic as well. So at least we tried 10 times, we didn't recover from it, but we still stored a message in this topic. And now it's up to us to decide what to do with it. But it depends on the implementation. So also here, Spring Kafka got you covered. Okay. Looking at the time, I think I have around 15 minutes left. So how about testing? When I first started with Kafka and Spring Kafka myself, I was of course learning, and I was quite heavily creating a lot of sort of integration tests. Spring Kafka provides you with this embedded Kafka annotation, and will basically spin up a single node Kafka broker inside of the test. Then you create another test, and you experiment a bit, and you see that those tests start biting each other. You put a lot of dirty context annotations on top of it, so everything keeps running. It gets slower and slower, and in the end, I was asking myself what I'm actually testing, because what ends up on Kafka is just bytes. Can I not better just test the serializer or other scenarios? And for a consumer, that might be isolated in a different service from the producer. So you are mixing producer and consumer concerns in one test. And then we started using Kafka Streams applications, and we stand up basically a full-blown end-to-end test where we start producing data, then consuming it, and verifying that data ended up on different topics. For example, for those the brancher that I just showed in the code. So at some point, we just kicked out basically all those tests and started looking into alternatives. One alternative is to use test containers. You're still doing integration tests, right? Because test containers will basically spin up a Kafka instance in the test, but it doesn't come directly with the FR schema registry. So you can, of course, mock this out, or it's still, for some cases it might be useful, but I try to avoid those kind of tests nowadays, and I would like to focus more on unit tests first. And for Kafka Streams, there is this topology test driver that's quite nice. It's a way to basically create unit tests for Kafka Streams applications without the need for standing up a complete cluster and FR schema registry and everything around it. So that's what I would like to show here. Maybe it's just good to open IntelliJ instead of the slides. So let's go to this Kafka Streams application. So once again, this is the code that we would like to test. That's basically branching off. Of course, if you're building more sophisticated Kafka Streams applications, this can be a bit more operations like joins and windowing and stuff like that. But to touch to keep it simple and touch the basics for now, we can basically use a topology test driver. We need to do a little bit of configuration here. We define the input topics, so that's the Stockwell topic. We also need to specify the other topics where we're branching off to. We have to, of course, tell that it's using Afro, what kind of service. It's for Kafka streams. It's basically a combination of a serializer and a deserializer. That's called a serde. So we need a little bit of setup here. This is all unit tests, and then we create the output topics. And yeah, if we really focus on the test itself, then we basically say, hey, we have this stock quote object. We fill it with some data. We produce this basically to the input topic. Since this is an ING stock, it's traded on the Amsterdam Stock Exchange. We can verify that the Amsterdam Stock Exchange topic initially is empty. After a little bit of time, it basically contains that message. If we read it back, it's exactly the same like we put in. That's quite obvious. But we also can verify that the other output topics are basically empty. And if we run this, it's super quick. And you can basically test your Kafka Streams application in a way more convenient manner. So this is basically what we advise teams to use. Yeah, maybe I can show one of the other tests for the consumer. Let's see here. I will share the link to the Git repo so you can play around with this afterwards. There's an example with Afro. There's an example with schema registry that we mock out. There's an example with test containers that's basically spinning up a Kafka broker. In the test, the nice thing is here that you can actually specify what Docker container you would like to run. We are using Confident Platform for Kafka, so I also would like to test against the version we are running in production, because sometimes with the embedded Kafka annotation, it feels like using an in-memory database for something you would like to test. So here you can really specify the Kafka distribution you're using. It's still quite fast, but over time this will get slower and slower. And I don't say you should never ever use it, but at least think twice and don't go full in on integration tests for Kafka. Okay. Then another thing is, of course, monitoring, right? We protected our application, we learned to handle exceptions, how to recover from it, and at some day we find out that the application is performing, we are lagging behind, customers complain they don't get data in real time. So if we look at the three pillars of observability, then logging is already covered by Spring Boot. And Spring Boot 2 basically offers a micrometer, which is basically the SLF4J for metrics. And we can really easily make use of the metrics that Spring is providing us. And if we add the Prometheus micrometer library, everything is set up for you to basically scrape our services, and I'm going to show that as well. Another thing is distributed tracing. If we would like to see in which part of the steps some latency is building up, or if we even want to see where messages traveled from producer to consumer to Kafka Streams application, we can basically start tracing that using Spring Cloud and Zipkin and Sloot. So it's just basically adding a dependency and configuring it a little bit to your needs, and then you're good to go. So that's actually what I would like to show as well. So let's go into the browser. In this setup, I have Prometheus here. So the Spring Kafka, the Spring Boot applications are basically having micrometer in there. And Spring Kafka will basically ship the consumer metrics from Kafka out of the box for you. There are a lot of metrics, so choose wisely which one to use because there are quite a lot. But I don't have to do anything to expose those metrics, and they will be using micrometer exposed in the way that Prometheus can scrape it. If we look here in the running Prometheus, instance on my local machine. I can see the targets. It's scraping, in this case, the producer, the consumer, and we can see some nice dashboards that should load. Let's see. Yeah, don't want to show this one. So in this example, I have a dashboard for both the producer and the consumer. So let's see here. So with those metrics that are just served for me, I can make a dashboard. This is actually one that's available on the Grafana dashboard, let's say marketplace. So you can basically use this one, maybe adapt it a bit to your needs. And we can see whether or not this consumer is lagging behind. And we can get all kinds of statistics out of our Spring Kafka application. So I think without a lot of effort, you have a lot of insights out of the box. One other cool feature is distributed tracing. And in this case, I'm using Zipkin. It also provides me with a really nice view. I hope it's visible, but I will explain it a bit. This is our producer application that's producing data to Kafka. We have the consumer application that's consuming it, and we have the Kafka Streams application that's basically consuming, branching off to different topics, and we can actually see how data is flowing here. But more importantly, if something is going wrong and latency is building up, we would like to see where things are getting stuck. Out of the box, if we go back here to the, let's see, producer, we can just pick one of those trace or span IDs. We can see it here, so let's pick a random one. So in the logging, you will see the span and trace IDs, and we can basically follow the whole flow. So if we take a bit deeper look in Zipkin here, we can see that our component, that's the scheduled stock quote producer, produces message in the produce method. Then the Kafka key was actually a Netflix stock. It was produced to the stock quote topic. It was produced to this broker. We only have one here, but it's called Kafka inside of Docker. And we can actually see that the Kafka Streams application consumed this one from that topic, from this broker, did its magic on the branching and produced it back to the NASDAQ topic, because obviously Netflix is traded there. But also the consumer application consumed this one. We can see it from the same topic, of course, and of course we only logged it here, but you get a picture, right? You can follow this message basically through the whole system that we have here. Also, this is completely included in the small code base that you can find on my GitHub account. So I think this is pretty cool to use and get the insights on distributed tracing. Okay. So out-of-the-box metrics for consumers, producers, streams, using Micrometer, the dashboard I showed you, distributed tracing, covered that. So I think it's almost time to wrap up. 2 minutes left, I see here. Okay, cool. So lessons learned. First of all, invest time in your local development setup. It will basically really quickly pay off because of the feedback loops you will get out of that. Use Spring Kafka, but also please learn the core Kafka APIs. Spring Kafka is a nice abstraction, right? But always also look into the core APIs to see how that works. As a consumer, expect the unexpected, like a poison pill. Make sure you can handle those. Look at proper exception handling. Also, validate your incoming data. I didn't show that really today, but it's another source of data that's coming into your application. And people might think, oh, it's Afro, but what if an email field is not an email, but it's a script tag that can be used for cross-site scripting or whatever, right? You still need to validate that data. That's not the purpose of Afro. That's still your responsibility. As a producer, don't change your serializers without either starting a new topic or really getting in touch with your consumers. In ING, we actually know who owns the topic, who consumes from it, so people can interact with those themes. Leverage Apache Afro and the Confluent Schema Registry. Don't break compatibility for your consumers. Yeah, think about security. Who can produce to my topic? Who can consume from my topic? Have some governance around it like we have in ING. Monitor, are you lagging behind? Are you think you're doing real-time analysis or real-time streaming? Are you actually doing that? You can only find out if you monitor that, and use Micrometer and Spring Cloud Sleuth that gives you those nice tools out of the box without a lot of hassle. For myself, yeah, don't overdo integration tests. Yeah, that were basically my lessons learned. Thanks for joining my talk. I think we might have time for 1 or 2 questions. If you don't feel comfortable asking questions, you can come to the ING booth. We'll be around there as well. This is the link for the GitHub repo, so if you would like to play around with it, feel free. That was my talk. Any questions?
Do you guys ever use exactly one semantics?
Okay, so the question is, do we have...
Do you guys ever use the exactly one semantics for transactional processing?
Yes, we see teams doing it. So let's repeat the question. Do we have one-time semantics? So it's basically that the consumer or your Kafka Streams application receives a message only once and guaranteed, right? This is only possible either with Kafka Streams, with transactions, and it's only within Kafka, right? If you're calling a downstream service, a REST API, that's not going to work. So yes, but there are some circumstances you need to have, right? You need producers that are producing in an idempotent way. You need to set up this. So it's out of the box. You need a bit of testing, right? So it's people can use it, of course. It's part of Kafka Streams, yeah, if you're not a producer, you also have to get in touch with those teams, because if a producer is producing multiple times, which are different messages, yeah, then right, there's more to it. It's a nice promise, but it only works in certain circumstances and configuration settings that you need to at least align. Yeah. And still, right, if you're receiving a message multiple times as a consumer, then you can still sort of get into the same behavior if your downstream component is idempotent, right? It can survive that, but you have to really think about those scenarios as well. I hope that answers your question a bit. Right?
Another small question.
Yeah, sure. Yeah, so the question is, what do we advise teams to do when they're making breaking changes in their Afro schema? Yeah, I think the most common way is, of course, not to break them, but if you really need to, then we advise teams to start producing to another topic. It requires a bit of a migration path, right? Because all the consumers needs to migrate to that new topic. So we'd like to try to avoid that, but if you really need to do this, then you need to synchronize with those teams. A lot of people advocate that everything is completely decoupled, but you still have your Afro schema, right? That's a contract. You don't have the coupling point-to-point communication, but you're still depending on that schema. You can just not throw that away and start over, because your downstream consumers or your Streams application will fall over. So basically starting a new topic is the way to go, yeah. But might not be the easiest way to get it through. Yeah. Okay.
Any suggestions on digital signing your messages?
So the question is, any suggestion on digital signing? Oh, that's a good one. Yeah, what we do is basically encrypting, but it's a bit different from signing. To be honest, I don't have a clear answer on that, but maybe we can chat afterwards to see what's available. Yeah. Yeah, good question. Yeah, let's take a look. Any other questions before the next speaker will arrive? Otherwise, walk by, or I will be in the ING booth afterwards as well. Thanks for joining.